Hey guys. Okay, so I went ahead and I printed that quiz review and all this kind of stuff, and I know some of you finished, some of you didn't, so I wanted to go ahead and just kind of go through it really quick. So this was number one, and if you haven't done this, so I'm going to post this, and if you're in third period, you didn't get this. So what you might want to do is you might want to pause it, go through this process, see what you can do, and then come back and watch the video to finish it up. So keep in mind, we always really want to see sine and cosine. We really don't want to see secant, tangent, cosecant, or cotangent. So I'm going to try to change things, substitute, so that I only see sine and cosine. The other issue that I saw in 8th period today, you can only work on one side of the equation, okay? You can't work on two sides. So you need to pick a side to try to match. I'm going to pick making this side, the left side, match the right side. So the first thing I'm going to do is I'm going to try to get rid of secant and cotangent because I don't like them. They're not invited to my party, if those of you who were in 8th period remember that. Okay. So secant x can be rewritten as 1 over cosine x. And cotangent x can be rewritten as cosine x over sine x. Now I am multiplying fractions together. If you remember when we talked about fraction rules, multiplying fractions together, you can cancel out things that show up on top and bottom. You can't do that with adding or subtracting, but multiplying you can. I am seeing cosine showing up on bottom and top, so I'm going to cancel those out. On top, I'm left with 1. On bottom, I'm left with sine x. I needed to verify that it equals 1 over sine x. I did that. I am done. Okay. So here's number 2. Again, you always want to work with the side that's got the most to do. You can only work with one. The left side has more to do than the right side because we've got a fraction that we could work with. We're rewriting secant. We can't really do a whole lot with 1 plus cosine. So I am going to, again, work on the left. Most everything you get, we're going to be working on making the left match the right. So the first thing I have to do, if you remember, I don't like secant. I'm going to rewrite that as 1 over cosine. And I'm already seeing that I am going to be dividing fractions. And if you remember from our little fraction operation review, dividing fractions, we're going to have to keep, change, flip. We cannot keep, change, flip right now. You have to get the top to equal one fraction. You have to simplify the top to be a single fraction by itself. So right now I've got 1 plus 1 over cosine. I can't add things that are not both fractions with the same denominator. So the first thing I have to do is I have to think about what would 1 be as a fraction. What would be 1 over 1? I'm going to write out everything, guys. You might not need to write out every single step, okay? But I, especially right now, am going to be writing out every single step. If you do that, you're going to need to write very, very small, okay? So now I'm looking at 2 fractions. Again, I'm just kind of concentrating on the numerator. I do not have like denominators. I need to try to figure out how to get like denominators. Well, I could multiply 1 by cosine, and that would create denominators of cosine in both fractions. But whatever I do in the bottom, I have to also do to the top. Okay? So now that gives me cosine x over cosine x plus 1 over cosine x divided by 1 over cosine x. Lots of cosines, lots of 1s. So for those of you who are saying that there's no numbers here, there are. They're just hidden. Okay? You might be going ahead and saying, hey, up top, I can put that into a single fraction because they have the same denominator. And I would say, yes, good. You can rewrite any fraction operation, well, addition, subtraction rather, as one fraction if you have the same denominator. So those 2 fractions can now be morphed into 1 over a single denominator. Now that I have a fraction divided by a fraction, and there's not a bunch of crazy stuff up top, I can keep, change, flip. Remember, we're keep, change, flipping because we are dividing fraction by fraction. So keep, change, flip. keep the fraction that is in the numerator exactly as it is. Change from division to multiplication. Flip the second fraction. At this point, we're multiplying fractions. We are able to cancel out anything that shows up on top and bottom, which for us are those cosines. I'm left with cosine x plus 1 over 1. Well, we know that anything over 1, that 1 is not really necessary. So I'm really left with cosine x plus 1. Well, guys, cosine x plus 1 and 1 plus cosine x, those are the same thing. Okay? Even though they're in different order, when you add things in a different order, that doesn't make a difference. So it's not a big deal to be able to just flip those two. And you're done. Number 3, again, left side to right side. We want to match this. There's obviously much more to do on the left side than there is on the right side. We're going to match the left side to the right side. The first thing I'm going to do, I don't like cotangent and secant. So I am going to rewrite cotangent. I'm going to substitute cosine x over sine x for cotangent. I'm going to substitute 1 over cosine x for secant. I can multiply fractions. Multiplying fractions doesn't have to be like denominators. Okay, so make sure that's known to you. You don't have to have the same denominator to multiply a fraction. It's not going to make us a huge difference here because cosine and cosine cancel out. So I have 1 over sine. Some of you might not even know at this point. You're dividing by fractions, which means you keep, change, flip. Keep, change, flip. 1 as a fraction, we just talked about in number 1. 1 as a fraction is 1 over 1. Change to multiplication, flip the second. You've got 1 times sine, 1 times 1, that all comes down to just sine. And you've got sine x equals sine x. All right, 4 got a little bit more complicated. Guys, you are looking for what you can do the most with. Now, this one might be a little bit difficult for you to figure out. As just kind of a word to the wise, you can't do a whole lot with sine and cosine. Okay, so that right side, there's not really a whole lot we could do with that. The left side, on the other hand, we can rewrite those things. So I'm going to go ahead and go with the left side. Cosecant, I'm going to substitute 1 over sine. Plus cotangent. Well, I know cotangent can have this substituted for it. If you are really confused with where these things that I'm substituting come from, you need to be going back to your notes and looking at your identities. Okay, a reminder. Quotient identities, Pythagorean identities, those are on your formula sheet. Reciprocal identities are not. So you would need to know, for example, that cosecant is 1 over sine. You would need to know that. But things like cotangent being cosine over sine, that's given to you. So back to just looking at what this is. I am adding fractions. That is what I am doing. In order to add fractions, I have to have the same denominator. I can multiply sine x by itself, and that would create sine squared. So that's what I'm going to do. 1 times sine is sine x. Sine x times sine x is sine squared x. I didn't change my second fraction because I was going to be able to create sine squared x as the denominator in the first one, so I knew that they were going to be able to have like denominators, and I was going to be okay. You're also noticing that I'm continuously writing what this is supposed to be equal to. 1, you should, because it's part of showing work. 2, it gives you that reminder that we already have what the answer is. So we know where we're going, we just have to figure out how to get there. Anytime you have the same denominator, that fraction can be rewritten as a single fraction over a single denominator. Even though it still looks kind of crazy, that was what we were looking for. There's not anything more that we need to do match the left side to the right side, and we are done. Stop when you match it. Don't keep going. All right, here's number 5. We're almost done, guys. We're getting there halfway. Again, you can't do a whole lot with sine and cosine. So that right side, there's really nothing that we can do. Those of you who are saying, wait, we've got cosine squared and sine squared, that's Pythagorean identity. The Pythagorean identity is sine squared plus cosine squared, and we have them subtracted. So no, we don't have Pythagorean identity there. So we are going to be working with the left side to make it match the right. So the first thing I'm going to do is I'm going to get rid of these cosecants. I can substitute 1 over sine squared x for that cosecant, and cotangent, I'm sorry, I said cosecants, there's only one. Cotangent can be rewritten as cosine squared over sine squared minus, I'm going to go ahead and put this as 1 over 1. I know that I'm going to have to, I'm looking ahead, and I know that I'm going to have to subtract those two fractions, which means I know they're going to have like denominators, so I'm going to go ahead and create that fraction because I know that's my next step. I need common denominators. Well, right now the denominator here is sine squared x. I need to get the denominator here to be sine squared x. Well, I can multiply 1 by sine squared x. Having a denominator of 1 is always really easy because you just multiply by what you need. Okay. Let's rewrite this whole thing again. You'll also notice, these problems typically take up a lot of room. Some of you are probably getting to the point where you can skip steps, and that's fine. If you start messing up, though, I'm going to tell you to go back and not skip any steps. Like some of you might go ahead and write this as a single fraction in bottom instead of taking that as a separate step in its own. Some of you are going to be able to do 2 steps at once, and that's fine. If you start screwing up, go back to doing each individual step separately. I have common denominators. I have this denominator here and this denominator here. They're the exact same thing, which means I can rewrite this as a single fraction. Keep in mind, you cannot keep, change, flip, which is what we're going to do because we have fraction divided by fraction. You cannot keep, change, flip until you have just a single fraction. Some of you might already see, hey, wait, both of those have sine as their denominator. We can cancel them out. That's okay. If you're not catching on to that kind of stuff, that's okay too. You can do all the math. You can keep, change, flip, and it's fine. You're going to get it. You just might take another step or 2, and that's fine. This denominator. Man, I'm redoing another step. I'm so sorry, y'all. Give me a second. We should be keep, change, flipping. Keep the first fraction. Change from division to multiplication. Flip the second fraction, which is a big one. I don't know if your hand's hurting, but my arm is hurting from holding it up and after I know this out before y'all. Take a look at this side, the left side. What do you notice? You should be saying you notice sine squared on bottom and top. That means those can cancel. I am left with 1 up top. I get cosine squared x minus sine squared x on bottom. Hey, take a guess. We're done. Good. Y'all didn't need to hear that announcement. That's it. And we're good. There's number 5. I feel like I'm probably beating a dead horse here, but guys, again, you can only work with one side of the equation to match the other side. You don't really want to work with something that has a lot of sines and cosines unless you have to. Let's work on the left to match the right. The first thing I want to do is I want to get rid of anything that's not sine and cosine. Well, tangent is not sine or cosine, so I need to substitute something for tangent. Sine x over cosine x. Then I'm looking at the denominator. I don't like that cotangent and I don't like that secant. Cotangent, we can substitute cosine over sine. Secant, we can do 1 over cosine. concentrating just on the bottom because I'm seeing I am dividing a fraction by a fraction, or fractions rather, which means I know I need to keep change flip, but I cannot keep change flip until the bottom just has one fraction. So I need to create the same fraction here. We don't have like denominators at this point. Okay, so we need to get like denominators. Unfortunately, we can't just multiply one denominator to make it the other one. So we're going to have to multiply one fraction by the other fraction's denominator. And go from there. So my numerator is still sine x over cosine x. My denominator, cosine times cosine is cosine squared. Cosine times sine is cosine sine. 1 times sine is sine. And cosine times sine is cosine sine. I still cannot keep change flip because I still don't have just a single fraction in that denominator. So I'm going to have to keep going with that. Well, they now have like denominators, which means I can rewrite them as a single fraction, which is what I really want. I'm getting close. All right, I can now keep change flip because I've got fraction over fraction. Keep change flip. First fraction stays the exact same. Second fraction flips. I am looking at these and I see right up here. So some of you might not have been able to see this, okay? But this cosine right here, because it's being multiplied by the sine, we can split them apart. Now, if those two were being added, I wouldn't be able to split them apart. But because they're multiplied, I can split them apart and then it can cancel out with that cosine. Only through multiplication. You cannot do that with addition. And that's just a fraction rule. Okay. I can't cancel anything else out. Like I cannot cancel this sign and this sign because of that addition that's happening there. You can only do that when it's multiplication. So that can't cancel out. So I am left on top with sine times sine, which is sine squared. And on bottom, I have cosine squared x plus sine x. And that is exactly what I am supposed to have. So I am done with that one. I believe that was number 7. I lied. Here's number 7. Again, we're making the left side match the right side. The left side's obviously very much more complicated. So I need to start with the left side. Cosecant, don't like it. 1 over sine. And because the cosecant was squared, the 1 over sine is squared as well. Minus cotangent, don't like it. Change it. Cotangent, don't like it. Change it. I am in that same exact, you should be kind of figuring out that there's only so many things that you can do. A lot of problems kind of follow the same process. We've done a lot of having to get 2 fractions morphed into 1 and then keep change flip, which is exactly what we're doing here again. Now, we do get lucky on this one in that those 2 fractions in the numerator already have the same denominator. So I don't have to worry about getting like denominators here. I can just go ahead and write it as a single fraction. All right. Now, my Blue Day folks, if you are watching this on February 1st or before you have class or like over the weekend or something, you are not going to know what I'm about to talk about. Gray Day folks, though, we have already seen these. So you have the Pythagorean identity here, okay? And it is right there, okay? We've got a 1 and we've got something squared that's going to tip us off to Pythagorean identity. You know, or it is in your notes rather, the Pythagorean identity, I'm not sure if your notes have cosine x or cosine squared plus sine squared, or if they have it reversed. It really doesn't make a difference. But that is the Pythagorean identity. It does not currently match what I need. I need the 1 to be positive and the cosine squared to be negative. So right now the 1 is positive. I need the cosine squared to be negative. I need the 1 minus cosine squared. So I need this minus cosine squared to be over here. So I'm going to subtract it from both sides. That cancels it out here. And this is something that typically is a struggle. The only way that you really get good at this is that you practice it. Now I see that that 1 minus cosine squared that I was working with over here, I could substitute sine squared in for it because they're equal. Some more room here. Okay. So at this point, we do have a fraction divided by a fraction, so we could keep change flip, okay, which is what I'm going to go ahead and do. Some of you might already see, hey, we've got sine squared x over sine squared x. That is 1, and you cancel it out to 1 before you keep change flip. Either way will get you the right answer. So I'm keeping, I'm changing, and I'm flipping. Right? Well, you have got signs that get to cancel, okay? And we can actually just cancel it from here. Sine squared and sine squared, they cancel out, they create 1. So I've got 1 times sine cosine. Guys, 1 times anything is just itself. So I really have sine x over cosine x equals tan. Well, according to your quotient identities, sine x over cosine x is tangent. Last one. So I'm actually going to show 2 different ways of doing this. One is going to be a very, very, very quick way that really is going to encourage you to know your Pythagorean identities. The other one is going to be a longer way that you would have to do if you didn't know your Pythagorean identities. So if I knew my Pythagorean identities, I would see, hey, tan squared x plus 1. According to my Pythagorean identity, that is equal to secant squared x. And I've got 1 over secant squared x. Well, 1 over secant is equal to cosine. So 1 over secant squared is equal to cosine squared. And you're done. If you know your Pythagorean identities, that is all you have to do for this problem. If you don't know your Pythagorean identities, let's check this out. This is going to be fun. If I didn't know my Pythagorean identities, I would come in and I would say, well, tangent is equal to, or tan squared rather, is equal to sine squared over cosine squared. 1 is 1 over 1. Because it's very obvious to me at this point, I'm going to have to add that fraction to 1, so I'm going to need common denominators and all that kind of fun stuff. Well, common denominator could be cosine squared x. Sorry for bleeding over into that other part. And I've got 1 over sine squared x over cosine squared x plus cosine squared x over cosine squared x. Actually, even this one, you still need to know your Pythagorean identities, that you can know the sine plus cosine one instead of your tan and secant and all that kind of stuff. I have like denominators, which means I can rewrite this as a single fraction on bottom. I see Pythagorean identity right here, sine squared plus cosine squared, that is equal to 1. Again, third period. You have not talked about Pythagorean identities yet. So me talking about that, you're like, what? It's okay. We will get there. All right, well, I have a fraction, or I'm doing fractions, I'm doing dividing. So that is keep, change, flip, keep the 1, flip the second, cosine divided by 1 is just cosine squared divided by 1 is cosine squared. Cosine squared times 1 is cosine squared, and so I just have cosine squared, which is what it said I should have. Okay, but you're seeing how much quicker, look how much work that was, and how much quicker just knowing my Pythagorean identities is. Okay, that first option is so much faster. So got all 8 problems under 30 minutes. Make sure you have got the work done. You've got your quiz next class. We can do a little bit of review beforehand, but you can see that I really want to make sure that you've got plenty of time, because if I can get through this in about 30 minutes, you probably would be doing somewhere between 45 minutes and an hour, maybe a little bit more. So I want to make sure we have plenty of time. So watch the other videos of the notes, okay? That will help you also.